This is a quick example of a t-distribution and using the t-table instead of a z-score. So you use a t-distribution, and the normal distribution assumptions that we make for a z-score do not apply. This is when we have a small sample and it's based on degrees of freedom. Degrees of freedom equals n minus 1. Always. That's your sample size minus 1. So if you notice on figure 611, we use a curve that looks like this. And then there are, it's supposed to be above, and then there are different t's. So a t-distribution of degrees of freedom equals 4, degrees of freedom equals 9, equals 14, and then equals 39. And then the normal distribution would be in my pen, and then I would have smaller distributions that would be representative of these different numbers. So when I am doing a sample and it is small, I use these assumptions rather than the z-score and the central limit theorem to represent or to find out what my confidence interval is. Again, this is the normal curve where we do not draw the same lines that we do for the z-score, and instead we're just looking at different iterations of the random curve, or sorry, the normal curve, with different degrees of freedom. This is not that helpful in understanding the t-distribution, but I wanted to make sure that I covered figure 611. Again, this is figure 611 in chapter 6. Table 6.2 is the t-distribution. So the t-table includes, it's useful for me to draw out what it includes. So if you notice on the left-hand side is your degrees of freedom. And again, this is always n minus 1. So you look up the degrees of freedom, and then you find out which critical value you want to use. This is based on your confidence interval. So our confidence interval, this is the little secret that I tried to explain earlier about the confidence interval. The confidence interval is the opposite of this number. So 100 minus 0.01, this is going to be a confidence interval of 99.9%. This is going to be the confidence interval of 99%. This is our 95% confidence interval. This is technically our 90% confidence interval. So when we see in the degrees of freedom table, for degrees of freedom of 4, our critical value is 2.13 at 10%. This means we are 90% confident that our data will fall within our calculation using 2.13. And then it goes to 2.78, and then 4.6, and then 8.61. So I'll show you how to use the t-table with the example right now. So the example that we're going to use, again, is also directly from the book. So we're going to use our information about this particular example. So we have a random sample with an n equals 15. So again, here's our sample information, n equals 15. Our mean equals 58. This is the notation for mean. Our mean equals 58, and our standard deviation equals 24.8. So that's our information that we're being given about this particular population. So we know how to calculate the standard error. So the standard error equals standard deviation over square root of n. So our standard error with 100 would be 2.48. But remember, we have an N of only 15 in this particular sample. So we are going to look at how to calculate the 95% confidence interval for this particular sample mean. So when we're looking at our t-table, we are going to be looking at our degrees of freedom. So I'll go ahead and grab a little t-table example that I had here directly from the book. So again, this is table number 6.2, critical values. These are already decided. These are published values. These never change. So table 6.2 is often found in the back of statistics books. So for the degrees of freedom for this particular example, I'm going to pull the degrees of freedom for 14 because our N, or our sample size in this example, is 15. So I'm going to write out the numbers. Again, this is directly from table 6.2. These are numbers that are published and already established. You do not calculate them. So I'll be using this information to finish my example. So when I am looking at the sample and I'm looking at the t-table, I'm going to go ahead and calculate my 95% confidence interval is going to look at the lower level. I've got my mean of 58 minus, here's where I calculate the confidence interval different. So instead of my z-score of 1.96, I'm going to go to my t-table. I'm going to find my 95% column, and that's noted by this 5% because I am 95% confident that this 5% is 100 minus 95. So I look at the 5% column, again, for my 95% confidence, and I get a critical value of 2.15. So I'm going to use 2.15 to calculate my confidence interval times my mean of 2.48 equals 58 minus 5.33 equals 52.67. And I'm going to do the same for the 95% confident interval of the upper boundary. And that's going to be calculated the same way. Again, I'm grabbing this t statistic from the t table. So this was a z-score before, now it's a t-table value. So 2.15 times 2.48, so this equals 58 plus 5.33 equals 63.33. So my confidence interval in this case is 52.67 to 63.33. My 95% confidence interval is in this range. So I am 95% confident that additional samples would have a mean between 52.67 and 63.33. And my mean for this particular sample is 58. So that's an indicator that you, the range in which you were able to predict future samples of the same variable. In this case, it's a thermometer variable.